Alright, now let's add the rest of our initial conditions that we need, even if they are zeros or even if they are not zeros, but let's simply add them. So we have x0, which we're missing, which is a 0. We have the xv, let's rename them. xv, which is the x velocity, xa, which is the x acceleration, which is also 0. Then we have the yv, then we have the ya, the acceleration on the y-axis. We also have y0, which we don't actually have, which is a 0. And we also have the different angles. So let's add the angles separated. X angle will be cos of the angle. Y angle will be sine of the angle. So let's see where we can reuse these values. Here we can use y of 0. So if y of 0 changes, this will automatically reflect it. So down here, we're going to use y angle. Here we're going to use x angle. Here we're going to use y angle and x angle. Same thing down here. X angle, y angle. So I'm very quickly going to document this. Alright, a bit of documentation, a bit of optimizations. Now let's move to the loops part. First, we need to generate multiple velocities. We're going to generate velocities on the x-axis from 1 to 10. And we also need 10 velocities on the y-axis. On the y-axis, we will generate velocities from 15 incremented by 1 up to 24. This will also give us 10 velocities. Now, the problem here is that we no longer can do this. We can't do this because now for each of the velocities that we have, we need to generate a different time vector, since the zero roots for the different velocities will be different, so each of them needs a different vector. So we are actually going to work with matrices. We're going to generate matrices for the x, y, and the t values. How are we going to do this? Well, first we need to change our initial vectors, their sizes. The x vector will be now a matrix. The rows will be as many of the velocities, so we will have one row of values for each of the velocities. So the first size will be the length of xv, the length of the vector, so we will generate 10 rows, and the columns for each of the row will be as many as the points that we have. Each of the other vectors will be of the same dimension. So here we will say size of x, size of x. Now, we need to recalculate the y roots for each of the y velocities. The way to do this, use a for loop. So for I equals to 1 to the length of the y, 1 to the length of the velocities on the y-axis, like that. And here, why? Because you will see in a second. Now, the y roots need to be recalculated for each of the velocities. So here, instead of using yv, we're going to use yv of I. So on every iteration of the loop, we will recalculate a new root. So let's run it. We will get many errors. I just want my variables to be initialized. All right. Now we can test it. We can say y roots of 1. Can we? Yes, we can, and we get a non-zero root of non-zero root, which is 2.16. If we use a different velocity now, if we use the second index, we get a different root. So that way we will generate new roots every time. The t vector, as we know, is dependent on the non-zero root. So here we don't have to change anything. The only thing that we have to do is generate vectors of the time for each of the velocities, or we actually have to populate its matrix. So when we calculate the y non-zero root for the first velocity, we're going to put it on the first row of the time vector, and we do the same thing with the rest of the vectors. So here we're now generating correctly the t vector. Now we need to move on. Here we have issues with the limits. Let's disable the limits for a moment and get our plot working. So run it. All right, here we have other issues. We have to now change the indexing for the t vector, and we also need to change the indexing for the x and y vectors. So how do we have to change them? We have to change the x and the y the same way we did with the t. So on every iteration of the loop, we are generating the whole x vector and the whole y vector. We're no longer calculating points in the vector, but we are calculating the whole vector. So here we're going to say get the whole current row. Same thing for the t vector. We need to select the whole row of the current t vector. And since our velocities are also different, here we have another t vector. Since our velocities are also different, they need only one index, like this. And our plotting will be a bit different. This is not going to work, but let's see if everything is now working. It's not working because here we have element by element operations. So we need to use a dot. Let's try again. Finally. So our vectors are correctly recalculated, but now actually everything changed. You can see now that we got another error. We got another error that we are trying to access an element from the xv vector which does not exist. So our for loop is no longer working on the time, but it's working on the velocities, on the different conditions. So here we need to change this to length of xv. If we try again, everything works with no errors. Finally. The plotting, however, doesn't work yet. We're trying to plot points. Instead, we must try plot whole vectors. So every time we calculate a vector and another vector, we want to plot it. Let's see. And it's kind of working. We get all of the vectors that we want, but we have to fix our limits. So let's remove this from here. Let's remove the colors altogether. Now, you can see that we get beautiful lines with different colors. We only have to fix our limits.